to another session of the Pilot Ground Briefs. My name is Habib Hussein, and I'm a pilot and a flight instructor. So before I get into the main content for today, I'll just like to take a moment to talk about Aero Global Aviation Academy. So here at Aero Global Aviation Academy, our main goal is to help people become pilots in an affordable and flexible way. So if you've ever been through flight training, or if you've ever been to a flight school, you know going through flight training is not cheap at all. So in order to successfully, achieve, our goal of successfully making flight training affordable, we do have to come up with ways to raise funds. So one of the ways we actually are also planning on raising funds is through the Pilot Ground Briefs program. So the Pilot Ground Briefs program is, a program that's there to help aviation enthusiasts or student pilots, sharpen up their knowledge. So we're putting it for sale out there right now. And, if you want to support us in this movement in making pilot training affordable, please consider purchasing the course. I know there's so many ways to, learn. There's so many resources out there to help you sharpen up your aviation knowledge. But just know if you do purchase this course, you're helping somebody out there successfully become a pilot. So with that being said, I'll just show you how you can get access to the course. And I'll come in here. If you do come here to this page on this link here, we currently have it on the Teachable platform. So you never know if you're watching in the future, the link might change. So please make sure you check the link in the description below for the most up-to-date link to get access to the course. But if you do come to the page here right now, you can scroll down to where it says to choose a pricing option. And we currently have the course going for $199. We just launched and we're doing a special early bird sale. So it might go up to the regular price of $279. But just like I said, the pricing is not the most important thing. The thing is, we're basically just using this to successfully raise funds so, we can keep our flight training operations affordable for people out there. So like I said before, if you do purchase, just know you're helping somebody else become a pilot, and you also be getting access to great content that's going to help you sharpen your aviation knowledge. So I look forward to seeing you in the course if you do purchase. And in the meantime, we'll go back and focus on the content for today. And thank you for listening. And start talking about your Pitot Static System. So the Pitot Static System has to do a little bit more with the actual instruments in the aircraft. So think about your airspeed indicator, your vertical speed indicator, and your altimeter. All these things are connected. All these things are basically considered as a part of your Pitot Static System. So there's two main parts to the Pitot Static System, which is the pitot tube and the static ports. So from this image here, we have the picture of what a pitot tube looks like and picture of what the static port looks like. So in a Cessna, for example, the pitot tube is sort of like a thing hanging out on the wing of the aircraft. The static port is a small dot to the side of the aircraft. So some aircraft have multiple pitot tubes just to measure the dynamic pressure from the airflow to determine the airspeed of the aircraft. So for the most part, the pitot tube is usually used for the airspeed indicator. And then the static port just measures static pressure from the surrounding air to determine your altitude and the vertical speed. So as you can see here, the static port is connected to all three instruments, but your pitot tube is only connected to your airspeed indicator. So all the three basic instruments on the Pitot Static System, they all use the static port, but only the airspeed indicator uses the pitot tube. So it's very important for you to. Then here we have, we're going to start talking about each specific instrument in the Pitot Static System. And we'll start by talking about the airspeed indicator. So the airspeed indicator, a few important things I want you to pay attention to in the airspeed indicator is the colors. So the colors are basically just telling you something about the airspeed indicator. This as a pilot is going to make your life a lot easier when you're flying the airplane. So as usual, you should always be scanning your instruments. But whenever you're within the green range obviously. Oh, I'll start by talking about the white arc. So this right here we have is the white arc, which is basically our flap operating range. So whenever the hand on the airspeed indicator, or whenever your airspeed indicator shows you're still within this white range, then you could use your flaps. But usually once you start exceeding this range, you want to make sure your flaps are not down at any point in time, because at that point it becomes dangerous. And then your green arc is your normal operating range. Your yellow arc right here, basically a caution, is considered a caution range. So you really do not want to fly in here unless you're flying in smooth air. And even when you're in smooth air, you still only want to fly there. You want to apply caution. And then you have the red line here, which is your never exceed speed. So over here, we also have a picture of what the airspeed indicator looks like under the hood. So I'll just give you a quick overview of how it works in general. So you have air coming through your pitot tube here, which goes into your diaphragm. So your diaphragm kind of like contracts and it expands and contracts as air comes in through your pitot tube. And then you also have your static airline here, which comes from the static port. So remember we said the airspeed indicator is connected to both the pitot tube and the static air. So as you can see here, there's a whole bunch of like levers and like pins here that's connected to what you actually see on the screen of the airspeed indicator. So the way the airspeed indicator basically works is, and you can read the 𝐷𝐿 to have like a deeper understanding. I'll just give you a general overview here. So the air comes in from the static port, and air also comes in from the pitot tube. So the air coming in from the pitot tube is dynamic air. So it's basically changing. So basically just measures the difference between the dynamic air and the static air that's inside the case, and it ends up showing you whether you're moving fast or if you're moving slow. It's basically just the difference between the static pressure and the dynamic pressure. And then you also need to know your different V speeds. So in general, for regardless of whatever aircraft you're flying, you always have a VSO, which is your stall speed in the landing configuration, determined by the lower limit of the white arc. So here it's considered the lower limit of the white arc right there. So that's your VSO. And then your VS1 is your stall speed in a specified configuration, which is clean, so with no flaps. So landing configuration is considered with flaps, clean is considered no flaps. So that is the lower limit of the green arc right there. So you have your lower limit of the green arc right there is your VS1. And then you have VFE, which is considered your maximum flap extension speed, which is the upper limit of the white arc. So you have your upper limit of the white arc right there, which is your maximum flap extension speed. So basically, once you exceed this speed, you do not want to have your flaps extended. And then you have VNO. VNO is your maximum structural cruising speed. The boundary between the yellow and the green arc right there is your VNO. Then VNE is this red line right there. It's basically your never exceed speed. And then VA is your maneuvering speed. So your maneuvering speed is not typically depicted on the airspeed indicator, but your POH will actually give you a range for your maneuvering speed. So it's important for you to always know what your maneuvering speed is. Usually, there's a way to calculate that based off of the weight of the aircraft, but I won't go into too much details on that. You can talk to your instructor to make sure you understand how to calculate that or how to reference that in the POH. And then we have the altimeter here, which is the next instrument that's a part of the Pitot Static System. So the altimeter basically is pressure sensing from the static port. So it's basically, it just uses the static port for the most part. And if you're flying in an aircraft that has a traditional steam gauges, this is what it looks like. It has like hands, it looks like a clock. So it typically has a Coleman window that helps you adjust for non-standard prevailing pressure. So typically what you do is before you fly, obviously you want to get the current pressure setting for the airport. So you set that in the Coleman window. This right here is considered the Coleman window. That way you get the appropriate altimeter reading for your aircraft. And then over here we have what the altimeter looks like under the hood. So these pictures are also in the 𝐷𝐿. So you can go in the system section of the 𝐷𝐿 and actually read through and see what it says about how the systems work. Or you can actually go watch specific YouTube videos that also give you a good sort of like pictorial representation of how everything works. So we have the static port here is connected to the case right here, and inside the case have something called an aneroid wafer for the altimeter. So the aneroid wafer basically contracts or expands depending on how much pressure is inside this case right here. So depending on how it contracts and expands, it moves these levers to show you whether you're climbing or you're descending. So that's how the altimeter works essentially. And then you have the next one we'll talk about is the different types of altitude. Since we're talking about the altimeter, it's important for you to know we have different types of altitude we reference in aviation. And I'll just go over them here. So you can have a true altitude, which is your actual height above sea level. And then you have the indicated altitude, which is what is shown on your altimeter in your cockpit. And then you have the absolute altitude. The absolute altitude tells you your height above the ground. And then you have your pressure altitude, which is your height above the standard datum plane. Standard datum plane is considered by the standard number 29.92. If you read from your altimeter, you can set that to 29.92. It tells you what your pressure altitude is. Then you have your density altitude, which is basically pressure altitude corrected for non-standard temperature. We already talked about this one when we're in the performance and limitations section. So as you can see, it's important to, be able to tell what the difference is between all these different types of altitude. And I also want to bring your attention to understanding your standard atmosphere. So your standard atmosphere is important for you as a pilot to know your standard atmospheric conditions with respect to your temperature and pressure. So you need to know your standard temperature is 15 degrees Celsius and your standard pressure is 29.92 inches of mercury. So on a general day at standard temperature, your pressure altitude is also a density altitude. And then here we'll talk about why your altimeter setting is important. So as you'll probably already know, if you're already flying, there's a 𝐊𝐿 window on the altimeter. So it's very, very important for you to always obtain your current altimeter setting and make sure it's updated, because if you don't do that, then your altitude may actually be all messed up, right? For example, if you turn your knob 1 inch higher in the 𝐊𝐿 window, the altimeter will read 1,000 feet higher. You can inadvertently do this flying from an area of high pressure to low pressure weather. So there's always a term that says from high to low, look out below. So we have an image here that shows you when flying from like an airport that has an altimeter setting of 30.74 to another airport that has an altimeter of 29.74. You initially set your altimeter setting to 25.74. It's showing you 5,000 feet here. You end up coming out here and it's actually showing you you're going to be at 4,000 feet. So it's important it's actually showing you you're going to be at 5,000 feet when you're actually at 4,000 feet, I should say. So, you can easily see how that could, become dangerous, because everybody else around you is most likely using the current updated altimeter setting. So if your aircraft is showing you you're still at 5,000 feet when you're actually at 4,000 feet, it's easy to see how dangerous that is. So this also applies to temperature. For example, if you're flying from a warm temperature to a cold temperature, if you do not adjust your altimeter setting, your actual altitude may be lower than what your altimeter is actually showing you. So it's important to be able to, update your altimeter setting and understand how that works. So the next instrument we'll talk about here, which is the final instrument that's connected to the Pitot Static System, is the VSI. So your VSI basically indicates your rate of climb or descent in hundreds of feet per minute. So it usually has like a slight lag due to delayed effects of the calibrated leak. So over here we have an image of what it looks like inside. So it's just a little bit similar to your altimeter, but the only thing it has here is a calibrated leak. So this calibrated leak basically leaks out whatever pressure is inside the case of your VSI. So your VSI also has a diaphragm, which is a similar instrument to what you have in your airspeed indicator. So what the diaphragm does is it expands and contracts, but the calibrated leak makes it happen a little bit slower. So just because the calibrated leak leaks the air a little bit slower, it takes some time for the levers and everything to catch up to the pressure inside the diaphragm. So that difference is basically what shows up on your VSI that tells you whether you're climbing or you're descending. So just remember there's a slight lag due to the delayed effect of the calibrated leak, just like I said. So, your VSI, it's always a little bit slower. For example, if you start climbing, it will show you, you're climbing, but, just know there's a lag in what it shows.